Welcome back, guys. So this is question number 46, and here I have to convert each of the binary number mentioned here to their octal counterparts. Okay, so previously we have seen that how to convert any decimal number to the octal numbers and octal number to their decimal counterparts. Similarly, we have also seen that how to convert any octal number to their binary equivalent. So here we are given the binary numbers and we have to convert them to their octal counterparts. So the procedure will remain same. Here we have all the numbers. So let me write them with this color. Here we are given the binary numbers. From binary, I have to convert them directly to the decimal numbers. Okay, and from decimal I can very easily convert them to their octal counterparts. Okay, so now let me start it from part A. So in part A I have 100 in binary. Okay, converting them to the decimal, what I have to do, as I have previously told you, that what I have to do, I have to write the bits here. Okay, and I have to multiply them with the what, with the base here. Okay, and then adding them and start writing the powers from 0, 1 and 2. Okay, so these will remain, this will become 0 because the multiplicative index will be multiplied with this 0 here. Similarly, here this will also be zeros, and here I will get 2 to 4. So the decimal equivalent of it is 4. Okay, what I have to do, I have to convert it to the octal, and we can very easily see that up to 7 all the decimal numbers are just like the octals. So the octal equivalent of it is also 4. Okay, so the binary equivalent of 4 is 100 and the octal number of it is this 4. So this is for part A. Now solving the part B of my question, what I have to do, I have to write here this 110. Okay, so this is part B, which is mentioned here 110. What I have to do, I have to write here 1. So what I will get here, it will become 2, this is 0, and here I will get 6. Okay, so as this is also less than 7, so here I will also get 6. So the equivalent of it 110 is also 6 in octal. Okay, so another number here we have is 11100. Okay, so now writing here 1100, and this is part C here. So 1100, writing the equivalent of it in the decimal number, what I have to do, so let me start it here. So 0 multiplied by 2. Okay, similarly the second 0 multiplied by 2. Okay, 1 multiplied by 2. Okay, and 1 multiplied by 2 as well, and start writing the powers from the right side base. So 0, 1, 2, 3. Okay, this is 0, this is 0, this will be 4. Okay, and this will be 8. So what I will get here, I will get here 12. So that is the decimal equivalent of 1100. Okay, now writing the octal equivalent of it, what I have to do, I have to use the repetitive division. Okay, so this is 12, this is 8. So now let me divide it over 8 and I will get 8 1. Okay, and the remainder of it will be 4. Okay, so we can see that here starting from here and here I will get 1 4. So that is 14 in the octal, because now this one is the most significant digit while this one is the least significant digit, and I have written them here. So the binary, okay, so the binary mentioned here is this one, while the octal equivalent of it is 14 8. Okay, similarly part D of it is 4 times 1. So writing them here, now removing them, this is D. So, this is 1 1 1 1, this is what, this is in binary, and converting to the decimal counterpart, I will get, it will be 15 in decimal. Okay. You may use the same procedure for the conversion which we have mentioned before, and converting it to the octal, what I have to do, I have to use the same procedure. So, this is the decimal number, this is the base, and 8 1 is 15, and here the remainder is 7. Okay. So, 1 7 is in octal. Okay. So, the equivalent of it in octal is this one, that is 1 7. Similar procedure will also be used for the other numbers as well, which I have used here, because first of all you have to convert the binary number to the decimal, and from the decimal you can convert the number to their octal counterparts. Okay. So, I think the concept is clear now, and in our upcoming video we will try to solve more examples like this one and try to clear more ambiguities in our upcoming video. Till then, take care of yourself, and I will see you soon.